Welcome to lesson 14, where we'll be multiplying, dividing, and estimating with scientific notation. I'll warn you right now, this video is going to be a little bit longer than it usually is, but there's a lot of good activities in here, so just bear with me. We'll be multiplying and dividing with scientific notation to answer questions about animals, careers, and planets. To be successful in this lesson, you will be able to use scientific notation and estimation to compare very large and small numbers. You're also going to be specifically working with multiplication and division when numbers are given in scientific notation. We start with the true or false with equations. Take a moment to decide if these three equations are true or false and have a reason as to why you said that. Pause the video here and then we'll discuss together. Okay, let's start off with this first one. This first one comes out to be false, and here's why. When you take a look at the exponents were multiplied and they should have been added together. So instead of having 10 to the 20th, we should have had 10 to the 9th based on the rules that we've developed in previous videos. The second one is true. If you divide those first leading factors, 7 and 2, then you can multiply that by the second factors, which is 10 to the 6th and 10 to the 4th, and we know that we have to subtract those exponents. This last one is false. Multiplication can be done in any order, but the multiplication in this problem doesn't affect the power of 10. So you can multiply the 8.4 and the 2 together, but the power of 10 has to remain 10 to the 3rd. Moving into the next activity, biomass. Think about this question. How many humans do you think there are for each cat in the world? You could see some fun pictures here to kind of help you brainstorm what you think about that. Large numbers like populations are often estimated using scientific notation. There's an estimated 7.5 times 10 to the 9th humans and 6 times 10 to the 8th cats in the world. So to kind of go back to that question, we could think about it like this. 7.5 times 10 to the 9th divided by the 6 times 10 to the 8th, so the estimated number of humans divided by the cats in the world. We can go ahead and think about this as 7.5 divided by 6, and then multiply that by the power of 10, applying that rule for quotient, subtracting the exponents. Thinking about this as 1.25 times 10 to the 1st, which is equivalent to 12.5. So there's roughly 12.5 humans for each cat. Now, part of our success criteria is to use estimation. We're going to use estimation in this activity to help us think of questions much more easily. So for example, estimating the number of humans for each cat could have looked like this instead. We could have said 7.5 is close to 6 and left both of those leading factors to be 6, which we know when you divide them, they're equal to 1. Then you would have just had to focus on the second factors of 10 to the 9th and 10 to the 8th being 10 to the 1st, which is equal to 10. So in comparison, our first one was 12.5 from this example here compared to 10. Now the final estimate is within 20% of the original calculation. It's not very accurate, but it is within a power of 10. Okay, so you're going to pause the video here. You're going to work through the 4 questions that have to do with the creatures, the number, and the mass of one individual. Take a moment to try this on your own, and then we'll discuss each of these components. So we start off by looking at which creature is least numerous and estimate how many times more ants there are. So the least numerous creature is the blue whales, and you can get that information by looking at the exponent. We're going to be comparing this to the ants, which is 5 times 10 to the 16th. So we're going to actually think about the blue whales, that 4.7 being close to 5. And so we're going to be dividing the number of ants by the number of blue whales, but using estimation to do so. So you can see 5 times 10 to the 16th divided by 5 times 10 to the 3rd. From this, we can say that there's about 10 to the 13th, or 10 trillion times as many ants as blue whales. So we would do 5 divided by 5, which gives you the 1. 10 to the 16th over 10 to the 13th, over 10 to the 3rd gives you 10 to the 13th. Question 2 says which creature is the least massive and estimate how many times more massive a human is. So we're going to be looking at bacteria because bacteria is the least massive. You see its exponent is to the -12. And then we're comparing that to the humans to see how many times more massive a human is. So we're going to be dividing again. We're going to do the humans divided by the bacteria. So we have 6.2 divided by the 1, which is still 6.2. And then 10 to the first divided by 10 to the -12th is just 10 to the 10 to the +13th because of that subtraction, 1 minus -12. So we can say a human is about 60 trillion times more massive. Now we were able to leave that 6.2 as is because we know anything divided by 1 is itself. Maybe if the situation was a little different, we would have estimated that number, but for this case, we really didn't need to. Question 3 says, which is more massive, the total mass of all humans or the total mass of all ants? And about how many times more massive is it? So here's our humans. And we're going to think about that number times the mass. So we're first going to take care of those calculations. So 7.5, we're working with multiplication, so we know we can multiply in any order. So we're going to go ahead and do 7.5 times 6.2, which is the 46.5. Then we have 10 to the 9th times 10 to the 1st. That gives us 10 to the 10th, applying the rules for our exponents here. So we'll just say that's about 45 times 10 to the 10th. Then we're going to go ahead and look at the ants. So we're going to take the 5 times 10 to the 16th, multiply that by the mass, which is 3 times 10 to the -6. 5 times 3 is 15. 10 to the 16th times 10 to the -6 is 10 to the 10th. So now we're working with the bolded blue and the bolded red. And we're going to divide the humans by the ants. So we know 45 divided by 15 gives us 3. And 10 to the 10th over 10 to the 10th is essentially 10 to the 0, which we know anything raised to the power of 0 is 1. So we can say that it's about 3 times more. Question 4 says, which is more massive, the total mass of all the krill or the total mass of all the blue whales? And about how many times more massive is it? So here's our krill. And we're again multiplying that number times the mass. So we're going to do the 7.8. We're actually going to estimate that to 8. And the 4.86, we're going to actually estimate that to 5. So focusing on those leading factors, 8 and 5, we know is 40. And then we're going to take care of that power of 10 by adding the exponents 14 and -4 together to get to the 10 to the power of 10. Now let's look at the blue whales. So we have 4.7 times 10 to the 3rd times the mass, which is the 1.9 times 10 to the 5th. We're going to estimate here as well. So we're going to say 4.7 is close to 5 and 1.9 is close to 2. We're going to take care of those leading factors. So 5 times 2 gives us 10. And then 10 to the 3rd times 10 to the 5th will give you 10 to the 8th. So we're going to go ahead and divide the krill by the blue whales. So we're now just those leading factors, 40 and 10 will give you 4. And then 10 to the 10th over 10 to the 8th will give you 10 squared. So that'll be 400 times more. Being able to multiply and divide quantities in scientific notation is particularly helpful for reasoning and estimating about very large or very small quantities, which would be challenging to work with in their decimal representations. So just a reminder, our criteria for this lesson, we're really focusing on estimation and then the multiplication and the division with the scientific notation. Moving into the third activity, we now look at the solar system. So take a minute here to just observe the values in the table. You're going to be answering the following questions about celestial objects in the solar system. You're to express each answer in scientific notation and as a decimal number. Pause the video here and go ahead and work on questions 1 to 4. Now that you've had some time to work, let's go through these questions together. We start by estimating how many Earths side by side would have the same width as the sun. So here's Earth and then the sun, and we're specifically looking at this diameter column. The sun is going to be about 100 times the width of Earth, and here is why. If we take that diameter of the sun and we divide it by the diameter of the earth, you can see that those leading factors are both close to 1. So we could kind of think about it as 1 divided by 1 just being 1. And then we have those second factors, 10 to the 6th and 10 to the 4th. Dividing those, you end up with 10 squared, which is where we're getting about 100 times, because 10 times 10. The next one says to estimate how many Earths it would take to equal the sun, or to equal the mass of the sun. So again, here's Earth, comparing this to the sun, and now we're looking at the mass. So the sun is about 300,000 times as massive as the Earth, and here is why. So thinking about dividing the mass of the sun by the mass of the Earth, written out as such. And then let's use estimation here to determine this. So we'll estimate that the mass of the sun is 2 times 10 to the 30th, and estimating the mass of the Earth to be 6 times 10 to the 24th, which makes it a little bit easier to calculate. So we can say that this is 1/3 times 10 to the 6th. If we were to think about that written out, we know that 1/3 is a repeating decimal. So that's where we're getting that estimate of 300,000, just kind of rounding it to that 300,000, especially because we rounded up when we estimated the 2 and the 6. And in this last one here, estimate how many times, the third one, how many times as far away from Earth the planet Neptune is compared to Venus. So here's Neptune, here's Venus, and we're looking at that distance to Earth. So we're going to say that Neptune is about 100 times as far from Earth as Venus. If we think about dividing Neptune, the 4.3 times 10 to the 9th, by Venus, both of those are close to 4, the leading factor. So we could think of it as 4 divided by 4, just being 1, and then just focusing on the 10 to the 9th and 10 to the 7th being 10 squared. So very similar to one of the previous questions we did. And in this last one, estimate how many Mercuries it would take to equal the mass of Neptune. Here's Mercury, here's Neptune. We're focusing on that mass column. So it's going to take around 300 Mercuries to equal the mass of Neptune. And here is why. Looking at the division of the mass of Neptune by Mercury, we're going to estimate that to be 1 and 3 for those leading factors, and then just focus on the remaining component with your powers of 10, and we would end up with 1/3 times 10 to the 3rd, which essentially, again, is a repeating decimal. So that's where we're getting that close to 300. So again, lots of information happening here. We have one more activity to get through. But again, our focus is the estimation, the multiplication, the division, all with scientific notation. Okay, so this last one, we're looking at professions in the United States. So estimation will make it much easier to answer the questions in this activity. You're given another table. You have a profession, a number, and then a typical annual salary. You're going to use this table to answer questions 1 to 4 about the professions in the United States as of 2012. Pause here, try it on your own, and then we'll come back together. Okay, so we start off by estimating how many times more nurses there are than doctors. So here's our nurses, here's our doctors, and we're looking at the numerical value. So there's going to be about 5 times as many nurses as doctors, because if we take the nurses, the number of nurses, the 3.45 times 10 to the 6th, divided by the number of doctors, we're using estimation here. So we're going to say that this is close to 3.5 and close to 7. And then again, those powers, the powers of 10 have not changed. They're still 10 to the 6th and 10 to the 5th. But we know 3.5 divided by 7 is 1/2. So we would say that this is 1/2 times 10 to the 1st, because we subtracted those exponents, 6 minus 5, for the division. This is equivalent to 5, right? If we think about that as a decimal, 1/2 is 0.5 times 10, that gives us 5. The next one says to estimate how much money all doctors make put together. So we're just looking at the doctors. We're taking the numerical value times the typical annual salary to find that total estimate. So we have the 6.9 times 10 to the 5th and the 1.87 times 10 to the 5th. We're going to use estimation here. So we're going to say that this is 7 times 10 to the 5th and 2 times 10 to the 5th. Then we just have to focus on those leading factors. So 7 times 2 is 14. 10 to the 5th times 10 to the 5th is 10 to the 10th because we add the exponents. So we can say doctors make about 140 billion put together. In the next one, we estimate how much money all police officers make put together. So we have our police officers, we're looking at the number times the typical annual salary. So again, we're going to use estimations. We're going to say 7.8 is close to 8 and the 5.7 is close to 6. Those leading factors, 8 times 6 is going to give us 48. We're going to add our exponents together for the powers of 10 to be 9. So we could say police officers make about 48 billion put together. This one says, who makes more money? All enlisted military put together or all military officers put together? So we have our military enlisted, our military officers, and we're looking at that number times the typical annual salary. So let's start with the enlisted military. So again, we're going to use some estimation here. We're going to say 1.16 is close to 1 and 4.38 is close to 4. Multiplying those leading factors together to give us 4, and then the 14 plus the negative 4 is going to give us an exponent of 10 for our power of 10. We go to the officers now, and we're going to say that in this case, because the leading factor is a 1, we could just multiply 2.5 times 1, and then just add those exponents together to get 2 to the 10th, which is, then we can estimate there to just say it's about 2. So in looking at that, all enlisted military put together make about twice as much as all officers put together. So a number is expressed in scientific notation if, again, the product of an integer, power of 10, and a number, if it is the product of an integer, power of 10, and a number greater than or equal to 1, but less than 10. So that was a lot of information, a lot of good practice. Read through that lesson summary if you need another refresher. Otherwise, you are successful at this lesson if you're able to use estimation, use multiplication, use division, all while using numbers that are given in scientific notation.